today the next tectonic theory that we are going to learn, seafloor spreading hypothesis and plate tectonic theory. Plate tectonic theory. In that, first of all, introduction, then seafloor spreading, hypothesis, in that we will learn basis of seafloor spreading hypothesis. In that, first, convection current, second, paleomagnetism. Paleomagnetism. So in that we'll also try to understand how seafloor mapping studies also provided or contributed to this particular hypothesis, seafloor spreading hypothesis. Then the actual hypothesis given by Harry Hess. With the help of diagram, we will try to understand. Then plate tectonic theory. But yes, before this, we will complete this theory. Then we will move on to next theory. Okay, so here lastly we will talk about the significance of this hypothesis. Okay. Yes. So in introduction, first of all, in continental drift theory of Wegener, in the earlier lecture we learned about this theory, and that theory proposed there is horizontal movement of land masses throughout the history of the earth, and this idea was further carried forward and studied in detail, and many such other studies help to explain the sea floor is expanding. This particular hypothesis that sea floor is continuously expanding, and along with that the forces which are responsible for the movement of these continents, these forces, adequate and satisfactory forces, were proposed through this theory. Okay, so in introduction, what we have understood here is that the idea which was proposed by the continental drift theory of Wegener was carried forward and further studied later on to propose the convection current theory of Arthur Holmes, which provided the basis for development of this sea floor spreading hypothesis. Okay, so first of all, let us understand the basis. And in that, the first concept, convection current. This convection current theory actually, which was given by Arthur Holmes. In 1930s, and this became the basis, or it provided the satisfactory adequate force responsible for movement of plates, lithospheric slabs, continents which are freely floating over the liquid asthenosphere. Now let us understand what is this convection current, how this convection current is formed. Okay, so let us draw one diagram here now. We will draw one diagram here, and through that diagram we will understand how these convection currents are working inside the earth. Simultaneously, I will advise you to draw this diagram in rough page, that will add to your practice. Okay. Now, okay. Continental mass, this is seafloor, this is mid-oceanic ridge, and this part is oceanic trench. This particular zone will be called as subduction zone. This is the convection current. Here you can say that magma is flowing in this convection current. Magma is flowing in this convection current in a cyclic manner. And that's why we are calling it as convection current. The subduction zone is on both sides, trench is on both sides. At central part, mid-oceanic ridge is there. Which is this region? Asthenosphere. Okay. Now, to understand what is happening inside the earth, first of all, you should be aware that as we go inside the earth from the surface to the interior, there is increasing temperature and pressure. In first lecture itself we have understood this, second lecture sorry. Now we can see here that the ocean surface or ocean bottom, ocean floor, at some places, or we can say whenever there is boundary between continental mass and the ocean surface, continental mass and the ocean surface, there is some kind of subduction of the oceanic crust is happening, and the new crust is being formed in the mid region, that is mid oceanic region. This is observed. And that's why we are saying that the sea floor is continuously spreading. But for this hypothesis, this basis, that is convection current theory, explains how this is spreading. Let us try to understand that. As we are saying that asthenosphere is the ductile zone. Asthenosphere is the ductile zone, ductile, or we can say fluid, moving part. Okay, now we can understand that there is increase in temperature as more heat energy is available in this region. Now you tell me, heat energy is available in this asthenosphere because of which reasons? We have learned this. Sources of heat inside the earth. Sources of heat inside the earth. Radioactive decay. First thing, radioactive decay. That means in this region, the radioactive material is continuously decaying, emitting heat energy. And then there is residual heat inside the earth. Since the formation of the earth, the residual heat that is remaining inside at present, the complete earth has not cooled. Okay, so since the formation of the earth, some heat energy is still trapped inside. That heat energy and largely this radioactive decay, this is resulting into more and more heat or temperature in this particular region, melting the available material in this region. Okay, now this is actually the lithosphere part. Now this lithosphere, which consists of crust plus upper mantle, when this part enters, or we can say into the region of asthenosphere where there is more heat, that gets melted. Now this melted material, whenever it finds the weak zone in the lithosphere, the upper lithosphere, whenever there are some cracks, fissures are there, it seeks to come up. Why? Because this is facing pressure and it wants to release pressure. How it will get released from the pressure? When it moves up, because there is less pressure in the upward direction. So to release that pressure, it seeks to continuously move up. The second aspect, you should be aware that melted material has many gases and water vapors. They are continuously trying to move up on the earth's surface. This melted material has some gases and water vapors, and that gaseous forms, or those gases, will continuously seek to come above the earth's surface through weak zones. And such kind of weak zones are created in this particular mid-oceanic region. Wherein this melted material from this asthenosphere rises above like this and suddenly comes above the earth's surface in a volcanic eruption forms. What happens here? There is volcanic eruption. This magma is coming up. There is volcanic eruption and that magma is getting solidified. Slowly is getting solidified, forming the new crust. Now as it is below the ocean water, that's why we can say that it is oceanic crust. Suppose the volcanic eruption is happening on the continent, then we will call it as a continental crust. Formation of continental crust. Here it is happening under the ocean, that's why it is forming oceanic crust. Okay. Now what happens when it is getting solidified? It is getting solidified on the vent itself. Now after over the period of time, when there is more and more pressure from the down, again there is sudden volcanic eruption as the vent get open because of pressure. And because of that, what will happen is the earlier crust is divided on the other side and moves like this on the both sides, getting new space for formation of new crust. Okay, so this is the process that is happening here in the mid-oceanic region. Now, as this magma is flowing in a circular manner or in a cyclic manner, forming the convection current in the asthenosphere region. This liquid movement or movement of this liquid is actually creating the basis for movement of lithospheric crust. You can see here, this is lithospheric crust, oceanic crust. This is floating over this liquid. And as there is a direction of this magma is like this and like this, what will happen to this lithospheric crust? It will float in this direction like this, See, the direction of the movement is happening because of the underlying currents and its direction. The direction is like this, and that's why the lithosphere, or we can say oceanic crust, is moving in this direction like this. So this is actually happening in a cyclic manner. The new crust is formed in a mid-oceanic region, and then it is getting separated, and then there is force in the opposite direction because of underlying currents flowing of magma, and then the new crust is getting older and older as it is moving towards this trench region. The new crust is getting older and older over the period of time as it is moving towards trench region. Okay, now trench region is that region where oceanic crust is getting subducted under the continental crust. Okay, as oceanic crust is heavier. How it is heavier? It is more denser. We have learned that in structure. That's why I was telling you we are going to use that concepts. As it is heavier and more denser, it is getting subducted. That's why it is getting subducted. So now it is clear that oceanic crust is getting subducted under the continental crust, and as this crust is entering into the depth, the temperature is increasing. Now earlier it was in solid form. As the temperatures increase and as it enters into the heat zone now of the asthenosphere, that crust is melted again and becomes the part of this cycle. That crust is melted again and becomes the part of this cycle or convection current. Again, in a cyclic manner, this is flowing like this. Okay, this is how the convection current theory proposed by Arthur Holmes. Now you can see the ideal force which is responsible for movement of the continents or lithospheric slabs, which is further proposed in plate tectonic theory. This force is provided by the magma that is flowing in convection currents. That is flowing in convection currents. That means whatever the land masses as well as oceanic floors that we have on the earth's surface, they are floating on liquid asthenosphere, and they are floating and moving in a particular direction because the underlying convection current is flowing in that direction. Because the underlying convection current is floating or moving in that direction. That's why the lithospheric slabs are moving in a particular direction. Okay, so can we say that this is satisfactory force as compared to that continental drift theory suggested by Wegener? Yes, now the scientists are of the view that yes, this could be happening inside the earth. This could be happening, and there are many such evidences in support of this theory now. Okay, so let us try to understand. After understanding this convection current theory, you understand that the force responsible for the movement of lithospheric slabs or the plates, continents, ocean floors, that force is provided by the convection currents of magma flowing underneath these slabs. Okay, one more time let me show that diagram to you. You may have received those files. Okay, yes, in colorful manner. Yes, lithosphere. Can you see lithosphere in a grey color? Okay, so suppose this is the ocean floor. This is the ocean floor. You can see the ridge part. This is mid-oceanic ridge, central part. In red part, you can see the currents of magma underneath lithosphere. Currents of magma underneath lithosphere. Can you see that the ocean floor is getting subducted, and here there is some continental landmass like this, and then there is trench. On other side there is also same case. There is trench. And the cycles are there in asthenosphere like this. Can we see that in the mantle part? Everyone is clear now after watching this? Everyone?
So,
yes, tell me.
So we can say that as the time passes, the depth of the trench increases due to this current.
As
The time passes, the depth of the trench will get increased due to the convection current because the cycle is happening again and again.
depth of
The trench.
depth of trench.
Oceanic,
Okay.
yes, the oceanic crust going inside
No.
the continental crust.
Yes, we can say that over the period basically the crust is getting consumed in the trench area. We'll talk like this. Okay, we'll say like this, that the continental crust or the oceanic crust is getting consumed in the zone of subduction created here in this location. This is called as zone of subduction or subduction zone. Use this word in your answer diagram specifically. So, zone of subduction wherein the crust is getting melted because of high temperatures and heat in that region, and that melted material is getting or becoming the part of that magma cycle. Okay, you should be also aware that this melted material also results into volcanic eruption on the continental masses, and that results into mountain ranges formations in this region. Mountain ranges formation in this region. We are going to learn that part. How the mountains are formed along the convergent boundaries, plate boundaries. This is convergent plane boundaries actually. Okay. This melted material of this crust suddenly tries to come upward and if that region lies below the continental mass, that results into volcanic eruptions and the formation of mountain ranges. For example, Rockies and Andes. Rockies in Northern America, Andes in Southern America. Basically, they are formed because of this reason. The continental American plates and oceanic Pacific plate. Oceanic Pacific plate is getting submerged like this under continental plates of North America and South America. That is resulting into volcanic eruptions and these mountain ranges along the plate boundaries. Okay, after understanding plate tectonics, you will understand all these things. They are linked with each other. Okay, so right now, just try to understand this internal mechanism that is happening, convection current. Now, after understanding this, let us understand the second basis, that is paleomagnetism. So yes, paleo means old at the time of origin, magnetism regarding magnetic properties of rocks. So paleomagnetic studies of rocks or the crust that is being formed in the oceanic region, that is oceanic crust that is being formed. So the study of those rocks or the oceanic crust, that has helped into understanding that the crust that is being formed in the ocean floor, that is relatively new as compared to continental crust. Along with that, here we are talking about the magnetism, that means magnetic properties. Properties of rocks in oceanic crust. This is studied in paleomagnetism. This is studied in paleomagnetism. Now, after the study of these magnetic properties, it is understood that the rocks which are formed in the mid-oceanic region, see the diagram here. This is very important. Earlier in magnetic field of the earth, we have seen there is geomagnetic reversals. We learned about that. There is geomagnetic reversals over thousands of years. In past, such reversal happened. Now, whenever the new crust is formed in mid-oceanic region, the magma is coming up, is getting solidified. Those crust or the rocks from that crust, they have some magnetic material. And when that magma is solidifying into the rocks, that magnetic material gets aligned with the geomagnetic field of the earth at that time. Okay, at that time. And now when it is getting separated and the new crust is being formed, the new rocks will be having the new alignment of the magnetic field at that time. This is how the paleomagnetic study of thousands of years of these rocks, we are able to understand the magnetic properties of these rocks have been reversed over the period of time, because the new crust is formed after thousands of years. That crust is moving like this, the rocks are moving like this. Okay, now it is understood that the rocks located on equidistance from the mid-oceanic region, they are having same magnetic properties. How did we understand that the sea floor is spreading? How did we understand that? Because the rocks equidistant from the mid-oceanic region, they are having the same magnetic polarity. That means they were formed at the same time. Their age is also same. Their magnetic properties or polarity is also same. That means they were once together and now separated on the either side of mid-oceanic region. Okay, so these studies, you can see here, the normal magnetic polarity is shown in this red color, orange color like this, and white color in between. The white color in between shows the reverse polarity. These magnetic stripes were understood, studied from the rocks, and then we are able to understand that the crust is being continuously formed in the mid-oceanic region, that is getting separated on either side and moving farther and farther from the mid-oceanic region, and ultimately entering into trench area for getting consumed. Now, how did we understand that the crust that is formed is getting consumed? Because the rate of spreading of the floor is not that high as we have expected. The new crust is being formed and it is getting separated. If it is happening, the ocean floors must be spreading at very faster rate. But that is not the case. That means somewhere that crust is getting consumed. That means somewhere that crust is getting consumed also. And this is how the trench areas came into the picture, where the older crust is getting consumed inside the earth. Okay, simply we have to understand that the rate of formation of new crust is much higher than the rate of consumption in the trench, and that's why the sea floor is spreading at slower rate. We are able to observe that also. We are able to observe that also. For example, the southern Pacific Ocean and the floor is expanding at 15 centimeter per year. 15 centimeter per year. So, because nowadays we are able to map the oceans, their distances through satellite studies. Now it has become very easy to understand how they are spreading, at what rates they are let's say spreading. Okay, so we have to understand from the paleomagnetic studies, we are able to, let's say, justify that the sea floor is spreading, the new crust is being formed in the mid-oceanic region, and the older crust is getting consumed in the trench area. Okay, this is actually a little bit difficult to understand, so let me again repeat that to you. The magnetic properties of the rocks, when they are formed in the mid-oceanic region, the magnetic material in that rock gets aligned to the existing geomagnetic properties of the earth, existing magnetic polarity of the earth, okay, at that time. Now, as these rocks are moving away and away over the thousands of years, new crust is also being formed here. Okay, so the earlier magnetic polarity of the earth might be different than the new magnetic polarity. The geomagnetic reversals, we have seen that. Okay, and because of that, we are able to understand there is stripes created like this. That means along this line, all the rocks have same polarity. Along this line in the ocean floor like this, they have same polarity, and adjacent sides or adjacent stripes or these rocks, they have different polarity. From this we are able to understand they are moving away from the mid-oceanic region in a, let's say, uniform manner over the period of time. Okay, so this is how paleomagnetic studies of rocks we are able to understand that sea floor is spreading. So the basis of explanation of the sea floor spreading further by Harry has these two important bases that has helped to propose. Along with that, the evidences of ocean, or we can say from ocean floor mapping expeditions that were undertaken during and after World War II. At that time, many such oceanic expeditions to map the floor of the ocean were undertaken by different countries. Okay, and through this expedition, it was actually found that there is a continuous mountain range within the ocean, or we can say inside the ocean. That means the mid-oceanic ridge. This is the longest mountain chain on the Earth's surface. It was found that through these studies or mapping, that continuous volcanic eruption is happening in that mid-oceanic region. Okay, so that again supports the evidence. The geodating of the rocks on the either side of the mid-oceanic region, that also suggests that these rocks were formed at the same time. Okay, geodating, that means the age of those rocks. When it was studied that these rocks which are at equidistance from the mid-oceanic region, their age is same. So that is again in support of spreading of the sea floor. At the same time, the deep trenches are found. Whenever the continental mass is meeting the oceanic floor. And from that it is understood that the old crust is being consumed in the trench regions. So this is how we have to understand the oceanic floor mapping expeditions. They supported the theory of the Arthur Holmes earlier theory and the paleomagnetic studies. Along with that, it became the basis for proposal of sea floor spreading hypothesis by Harry Hess. So from this, the hypothesis was given by Harry Hess, Professor Harry Hess, and according to this hypothesis, it says that the ocean floor is continuously expanding, new crust is being formed, in mid-oceanic region, and old crust is consumed in trench area. The force responsible for movement of oceanic crust is convection current of magma. Convection currents of magma in the mantle or asthenosphere. This was the hypothesis given by Harry Hess. This was the hypothesis given by Harry Hess. Okay, once again we'll look at the diagram. Another diagram which shows the picture of what is happening on the earth's surface also. What is happening on the earth's surface also. Yes. Now look at this diagram. This image shows there is continuous formation of the crust, like magma is coming up in mid-oceanic region. Look at this region. Then the lithosphere or the oceanic crust is moving like this. You can see here the oceanic crust moving like this, moving like this. Then there is trench area like this. Here also there is trench area. Okay, and in that there is subducting plate, or we can say there is subduction of this oceanic plate like this. Here also there is subduction. Okay. Now you can see here the oceanic ridge is formed, continuous oceanic ridge at the central part of the ocean floor, and the different land masses or the solidified crust is moving on the other side like this and getting consumed in the trench region. The remaining part again we will learn that in the plate tectonics, different kind of plate boundaries, how they are created on the surface because of interaction of these different plates. Okay, have you understood this? Any question regarding this? Yes, everyone.
So regarding the convection current,
Yes.
so can you explain once again?
Yes, convection currents. Look at this diagram again. See, inside the earth, especially in asthenosphere area, the sources of heat, two important sources of heat: radioactive decay of radioactive material, creating the heat energy, along with that residual heat. Now, because of that, there is continuous melting of the material in that region, and melting of material leads to formation of magma. Now this is magma is fluid, it seeks to flow in a certain direction. It seeks to flow in a certain direction. Whenever there are density and temperature differences created, whenever there are density and temperature differences created, can you see the density and temperature differences in the upper part and lower part? These differences actually are responsible for movement of this magma in a circular manner like this. Right? Convection happens even in the atmosphere. The convection happens. The air or the wind is getting heated near the earth's surface, and the heated, expanded and low dense high temperature wind is moving up, and the colder, more denser wind is coming down. Again it is getting heated, again it is moving low. So there is convection current of wind or air above the surface also, earth's surface. The convection happens because of temperature and density differentiation. Here the temperature and density differentiation along the depth. Okay, and because of that, what is happening? The magma is moving in a circular manner like this. Okay, now whenever there is weak zone is found, this magma tries to move up towards the low density region or low pressure region also, you can say. Now when it is moving up, you can see the weak zone, it is found in a mid-oceanic region. Okay, here the magma suddenly erupts in the form of volcanic eruption. Okay, and at the same time all magma is not coming up, it is moving in a opposite direction like this, forming the cells.
So the video is lagging.
Yes, everyone?
So the video is lagging.
Everyone's facing same problem?
From my side, correct.
Okay, so Ali, please check internet connection. Yes. So the magma is not only coming up, rather it is also flowing in this manner. Now it creates, try to imagine, just try to imagine that suppose there are broken pieces of woods, they are floating on water surface in a container. Try to imagine that. Now suppose there is water is flowing in a certain direction, those wooden particles will try to move in that direction itself, right? Because there is underlying force created by that liquid, right? The same thing is happening here also. The lithosphere, that is the oceanic crust now, lithosphere, that is oceanic crust, that is floating over the asthenosphere. Okay, now this particular movement of magma in that direction, in the asthenosphere, that leads to movement of the lithospheric oceanic crust in movement of that direction, or here in this part in opposite direction. Okay, again this particular lithosphere, the new crust that is formed here is moving along, or we can say because of this movement of magma in this direction, it is also moving in this direction. Now this is happening over thousands of years. Okay, so older crust is getting near to this trench area and getting subducted because of high density of oceanic crust. Again I am telling you, if the continental crust would have been more denser, then continental crust would be subducting under the oceanic crust. But this is not the case. The oceanic crust is more denser, and that's why it is getting subducted. When the subducted crust is getting into more depth, then again there is increasing temperature, pressure, and it is entering into more heat region. It is getting melted and becoming part of asthenosphere or this particular convection current. This is how, this is a kind of self-sustaining currents that are going on. But let me tell you that once the radioactive material is depleted, once the radioactive material inside the earth is depleted, then that cycle will weaken and ultimately stop. Okay, that cycle or those currents will get weakened because source of heat is reduced or ended. Okay, have you understood now how it is working?
Yes, sir. So my question, due to the convection currents, right? So am I audible?
Yes, tell me.
So due to the convection currents, the magma from the interior of the earth, from the asthenosphere, will come out.
Yes.
The oceanic ridges.
Yes.
Yes, so but the oceanic ridges is situated in the ocean.
Yes, last statement, will you please repeat?
So the mid-oceanic ridges is situated in the center of the ocean, right?
Not always center of the ocean. To some extent, we will say that center of the ocean.
Yes, sir. So, sir, when the molten magma will come out, it starts getting deposited
Yes.
from the both of the sides, and when it gets solidified, igneous rocks are formed.
Yes.
And from time by time, the rocks will get gathered, right?
Yes, it is moving in opposite direction.
Direction. Yes, sir. So, how this will make the continental mass move?
It is not making continental landmass or continental crust. We are going to learn that separately. Try to understand, the continental crust is created because of volcanic eruption below the continental mass. In this diagram, later on we are going to learn this. Okay, so yes, some part of the melted material becomes the part of this current. The other part also gets as a part of volcanic eruption and the mountain building activity along these margins. You can see here, suppose imagine that these are Rockies or Andes. You can see here, suppose this is the North American plate. Then these are the Rockies mountains. How these Rockies mountains are created? Basically it is continental crust. The new continental crust created. That matter is coming above from the asthenosphere in terms of volcanic eruption here. That means you can see here the melted material of the oceanic crust in this region is coming above the continents, continental masses. Is coming above the continental masses. That means the similar kind of process that is happening in mid-oceanic region, a similar kind of process happens at the boundaries of two plates when they are converging. Here the plates are diverging, here the plates are converging. In plate tectonics we are going to learn about this. In plate tectonics we are going to learn about this. Okay. So here the continental crust, new crust is created in terms of volcanic eruption and mountain ranges. Okay, is this clear now? Any other question? Yes.
Sir, regarding the term that picture, continental crust and volcanic heat will be coming outside through volcanic form. And that particular area it may cause to loss of water reserve sources of contact.
Yes, yes, yes.
Can we assume same process, whatever the reserve water has been low stage, same process will be occur on that particular area? Example, desert, some water low level areas. Can we assume same process will be occurring on that particular area? Example, some South India having low water reserve sources.
Water reservoirs.
No, sir. Water reserve sources, low level of water.
Okay, so water reserves you are saying.
Yes, sir.
Okay.
The same process is going to be applied on that particular area, sir, or any other process is going on inside of Earth.
Inside the earth, in what water reserves you are saying? Groundwater reserves you are saying, or surface waters?
No, sir. Groundwater reserves.
Groundwater reserve. See what happens, try to understand when this volcanic eruption is happening. This volcanic eruption largely happens along the plate boundaries. Okay, I am repeating again and again. It happens along the plate boundaries largely, whether it is convergent, that is two plates are coming together, or divergent, that two plates are going away from each other. On both sides, both locations, the volcanic eruptions happen. Suppose in the path of this volcanic eruption there is groundwater reserve. Suppose in the path of this volcanic eruption there is groundwater reserve that is getting evaporated, and there could be violent volcanic eruption because of that. Violent volcanic eruptions happens because whenever there is gaseous pressure created through that, we can say water vapors. Okay, water vapors, whenever they are present in volcanic eruption, there is a huge explosion happens in those volcanoes. Explosive volcanoes are those volcanoes which has some kind of gaseous ingredients. Okay, is this clear? Yes. Any other question? Now the significance part, last part. In significance we can say that this seafloor hypothesis it led to further development of plate tectonic theory, or we can say basis for plate tectonic theory, which explains formation of different landforms on the Earth's surface. On the Earth's surface. So in significance part, significance of theory, it became the basis for development and plate tectonic theory, which satisfactorily explains the formation of all the landforms on the Earth's surface. Okay, so this is how we have to understand the significance of seafloor spreading hypothesis. Let us first write down about this hypothesis and then we will continue with plate tectonic theory. Okay? Yes. So first write down this part, then we will write down some questions about seafloor spreading. Previous year questions, there was one question. Yes, in 2010 there was one question, write down. Write brief but precise note on seafloor spreading. Write brief but precise note on seafloor spreading. Yes, next, write down, explain the seafloor spreading hypothesis. Explain the seafloor spreading hypothesis with the help of appropriate diagram. With the help of appropriate diagram. Next question. What is convection current? What is convection current? What is convection current? How, next part of the question, how does it help to explain? How does it helps to explain the fact that seafloor is spreading? The fact that seafloor is spreading. Okay, so yes, the different framing of the question can happen, but the essence here is regarding the seafloor spreading theory. Fine. So let us write down. First of all, introduction. The idea of continental masses, moving in horizontal direction the idea of continental masses moving in horizontal direction as given by continental drift theory, as given by continental drift theory, was further studied in depth, was further studied in depth this led to development of seafloor spreading hypothesis. This led to development of seafloor spreading hypothesis and subsequently the plate tectonic theory. And subsequently the plate tectonic theory. Subsequently the plate tectonic theory. Next, the seafloor spreading hypothesis is based on first convection current theory, second paleomagnetism, convection current theory and paleomagnetism. In that, first we'll write down about convection current theory. Convection current theory. It was given by Arthur Holmes in 1930s. It was given by Arthur Holmes in 1930s. According to him, next point, according to him, there exists a system of convection currents. There exists a system of convection currents of magma, convection currents of magma in the entire mantle portion. Convection currents of magma in entire mantle portion. These currents are generated due to the thermal differences in the mantle, portion caused by radioactive decay, Let us draw this diagram now. Everyone,
only radioactivity or residual also.
sorry.
So only we have to mention about the radioactive decay or the residual decay.
Yes, you can mention residual heat also, but majority of the heat contribution is by radioactive decay. Okay. Yes, you can add residual heat also, a supply of energy, heat energy. Okay. Draw this diagram here. Naming of the diagram is very important. Okay, subduction zone, then continental masses, or we can say lithosphere, oceanic lithosphere or mid-oceanic ridge, trench region. The diagram which we have provided in the PDF, that is also good simple diagram. You can draw that also in answer. Okay, let us write down next point in the same. The movement of magma in the convection current. The movement of magma in the convection currents provided the basis for in bracket force in bracket force bracket close for movement of basis for in bracket force bracket close movement of lithospheric plates, movement of lithospheric plates. Scientists today, next point, scientists today consider this force as adequate and satisfactory. Scientists today consider this force as adequate and satisfactory as against the forces given by Wegener in continental drift theory, given by Wegener in his continental drift theory, Okay, now after this we will write down about the paleomagnetism. About the paleomagnetism. It is the study of Earth's magnetic field. It is the study of Earth's magnetic field with the help of magnetic fields recorded in the rocks magnetic field recorded in the rocks and sediments. Magnetic field recorded in the rocks and sediments. Over the long time period. Yes. Rocks which are formed in the mid-oceanic region. Rocks which are formed in a mid-oceanic region after solidification of basaltic lava. After solidification of basaltic lava contains magnetic minerals. These minerals align themselves in the direction of magnetic field of the earth. Align themselves in the direction of magnetic field of the earth present at that time. In bracket the geomagnetic polarity can be normal or reversed. Bracket closed. Geomagnetic polarity can be normal or reversed. Bracket closed. Next, the paleomagnetic studies of these rocks. Have shown that the Earth's magnetic field has frequently changed has frequently changed over the time period. Has frequently changed over the time period. Next, after studying the rocks on either side of the oceanic ridge, after studying the rocks on either side of the oceanic ridge, it was found that there is alternate bands of magnetic rock stripes. There is alternate bands of magnetic rock stripes with normal and reversed polarity. With normal and reverse polarity. You can simply draw one diagram, show it like a three-dimensional slab. Okay, let us draw that diagram, because whenever you are explaining something, if you draw a diagram, it becomes a very enriching part in your answer. Like this, three-dimensional diagram. You can draw like this. Right. And here in the center you can show like this, that magma is coming above, and then there is formation of mountain ranges in this part. Okay. You can show either this in red color . Now they are getting separated on either side. So simply now show the bands of alternate polarity. Okay. You can draw simply like this, one color, or if you are not going to use the different colors, simply what you can do is draw like this. Okay, so you can show that the middle part is having reverse polarity, this is normal polarity, then again reverse polarity, normal polarity. Such kind of rock stripes can be shown with the magnetic properties of normal polarity and reverse polarity. Okay. Small diagram can be drawn. Whenever you are writing answer to the geography question, maps and diagrams, they become very important. Diagrams in physical geography part, maps in human geography part, because human geography part involves resource distribution, industries and their location, that requires map part. Okay, so map of India, we will try to draw that in Indian geography part also, how to draw map of India. Okay, yes. After drawing this, write down this evidence in support this evidence in support to the concept of seafloor spreading, became the basis for seafloor spreading hypothesis. Now write down about seafloor spreading hypothesis. It was given by Harry Hess. It was given by Professor Harry Hess. According to him, the ocean floor is expanding. The basaltic magma rises from the weak zone in mid-oceanic region. The basaltic magma rises from weak zones in mid-oceanic region and cools down to form new oceanic crust. This new oceanic crust slowly moves away from the ridge, under the influence of convection current, flowing underneath it. Convection current flowing underneath it. The older crust when reach trench area, it is getting consumed. When it reach trench area, it is getting consumed in subduction zone. Okay. Evidences in support of seafloor spreading hypothesis. Seafloor spreading hypothesis. The mapping of ocean floor through various expeditions during and after World War II. During and after World War II. And the paleomagnetic studies of rocks have revealed the following facts. First, volcanic eruptions are common all along mid-oceanic ridges. Volcanic eruptions are common all along the mid-oceanic ridges. Bringing huge amount of lava to the surface. Second,
So can you repeat the previous one?
yes, volcanic eruptions are common all along mid-oceanic ridges and they bring huge amounts of lava to the surface. Second, rocks equidistant on either side of mid-oceanic ridge. Rocks equidistant on either side of the mid-oceanic ridge show remarkable similarities in terms of age of formation, chemical composition, and their magnetic properties. Next point. The age of rocks increases as we move away from the mid-oceanic ridge. The age of rocks increases as we move away from the crest, or we can say mid-oceanic ridge. That means new crust is being formed in mid-oceanic ridge. Next point. Oceanic crust rocks are much younger than continental rocks. Oceanic crust rocks are much younger than continental rocks. Age of oceanic rocks or oceanic crust rocks is nowhere more than 200 million years. Is nowhere more than 200 million years. While some of the continental rocks are as old as 3,200 million years old. 3,200 million years old. Next point. The trench areas have deep focus earthquake. The trench areas have deep focus earthquake. While mid-oceanic areas have shallow focus earthquake. While the mid-oceanic areas have shallow focus earthquake. Okay, so these facts actually support or act as a evidence that the sea floor is spreading, new crust is being formed in mid-oceanic region, and the dating of these rocks also suggests that there is spreading of the sea floor. Okay, so you should be mentioning these evidences in support. Now, after writing this, write down the significance. Significance. Sea floor spreading hypothesis became the basis for development of plate tectonic theory. Became the basis for development of plate tectonic theory. Which satisfactorily explains formation of different landforms on the earth surface. Formation of different landforms on the earth surface. Okay, so this was about sea floor spreading hypothesis. Now, the next part, yes, tell me.
So if the question is asked, how can we able to manage with 3.5?
Yes, what you are saying?
So if this question is asked in the exam, how it is manageable to write so much of information in 1.5 page?
Yes, this is the task. This is very important aspect. First of all, try to understand that in geography, what is, or even in any, let's say, part of our syllabus, what is asked in the question, we have to write answer accordingly. Now take any question from the questions we have written, or suppose directly the UPSC question that was asked in the mains examination itself. Write a short account or note, write a brief but precise note on seafloor spreading. Suppose this is to be written in 100 or 150 words. Brief note. First of all, in introduction part itself, write about who proposed this theory and the basis of theory. Simply you can write down that the theory was proposed by Harry Hess, and it explains that, or it proposes that the sea floor is continuously expanding. This much can be the introduction. Okay, introduction should be short and precise, in exact manner and relevant to the question. Okay, now after writing this, the basis for this hypothesis is convection current theory and paleomagnetism studies. Okay, after writing this, draw the diagram directly explaining convection current theory. You need not to explain the convection current theory here now. Okay, because once you have written that, it became the basis, the diagram itself explains now. Okay, now in description of this theory, you should explain the basis, that is the force responsible. The force responsible for the expansion or spreading of this lithosphere, oceanic lithosphere, that is nothing but the convection current. Okay, and simply the description, just now we have described the seafloor ocean spreading, that is the new crust is being formed in the mid-oceanic region. The older crust is moving farther away and away because of the direction of the convection current or the magma in the convection current, and then the older crust is getting consumed in the subduction zone. This is the continuous cyclic process that is going on inside the earth. The evidences in support of this hypothesis are as follows. Write down 3 to 4 important evidences, and lastly, in conclusion, write down the significance. That's all. Are we able to write down this in 150 words now?
Yes, sir, sure.
What is important in your answer in this part is you should draw the diagram. Second thing, you should explain the force responsible. The force responsible is that convection current that is created due to the radioactive decay, the thermal differences in the mantle portion due to radioactive decay. Once you mention this, the examiner will understand, you understand the theory, he will give you full marks. Okay. Because the evidences and, yes?
Yes, sir. Sir, the diagram of the convection current theory, the whole diagram, and then the formation of the trenches. The two diagrams are uniform, right?
No, only one diagram. Even you need not to draw that magnetic reversal and magnetic stripes. Just mention that the ocean floor studies and mapping expedition, they have helped us to understand that the rocks equidistant from the mid-oceanic region, they have remarkable similarities in the formation, age of formation, chemical compositions and magnetic properties. That much is sufficient because that is given in NCERT. What we have understood in the classroom is for your conceptual understanding. Okay, in classroom we are going further one step ahead in understanding this concept. Okay? Yes?
Yes, sir.
Okay. Yes. Fine. So now the next theory is plate tectonic theory. This is very important because many questions have been already asked on this theory and its application. Plate tectonic theory. In this introduction, then we'll write down in theory, first of all, description, in that what are lithospheric plates, second thing, why and how they are moving, and the different kind of plate boundaries which are created. Three types of plate boundaries are created because of movement of these plates. Okay, what are different lithospheric plates? And then we can say that here itself we will try to know which are major and minor plates, in the world on the Earth's surface. And finally, three plate boundaries and their interaction. Okay, so that becomes the part of next session itself, but we will include here itself. Interaction of different plates and resultant landforms and processes. This is very important. Nowadays questions are being asked from this part. Resultant landforms and processes, like formation of festoons and island arcs in Philippines region. Okay, there was one question in UPSC Mains examination. Or formation of Japanese islands, group of islands, formations of Caribbean islands, formation of Himalayas, folded mountains, or formation of Rockies and Andes. So yes, different plate margins or plate boundaries, their interactions and how they are resulting into these different landforms on the Earth's surface. Okay, so after understanding this, overall we can write down in conclusion part, regarding this plate tectonic theory. Finally, okay, so this is how we are going to proceed here regarding plate tectonic theory. Let us try to understand the concept today. Dictation we will know it tomorrow. First of all, in introduction, like every other theory, what we are doing here, we are giving some background. Okay, background here also in plate tectonic theory, what we will give the background? The continental drift theory and seafloor spreading theory provided the basis for the development of this idea of movement of continents or lithospheric slabs moving in a horizontal directions. Also, the seafloor spreading theory or hypothesis provided the force responsible for movement of these lithospheric slabs or land masses. Okay, that led to further development of plate tectonic theory. Now this plate tectonic theory in detail, let us try to understand. First of all, what are plates or lithospheric plates? Basically, we have to understand that these plates are nothing but the masses of lithosphere landmass, or we can say land. Okay, so lithospheric land or lithospheric slabs, huge land masses. These plates includes not only continental land masses but also oceanic crust. Okay, so these are actually lithospheric slabs of continental landmass or oceanic crust or together, both continental and oceanic crust. So it depends on, let's say, majority of the area covered. Suppose the majority of the plate is covered by continental landmass, then it will be called as continental plate. Suppose the majority of the landmass is covered by oceanic floor, then we can say that it is oceanic plate. For example, Pacific plate. Pacific plate is oceanic plate because the majority of the area is covered by oceanic crust. As against this, if we are calling it African plate, majority of landmass is covered by continental landmass, and that's why we will call it as a continental plate. Okay, so this is how we have to categorize them also. But can we understand the difference from the continental drift theory and plate tectonic theory here? What Wegener considered in continental drift theory? Continents and oceans as separate landmasses. He considered the continents and oceans as separate landmasses, and he considered that Sial is floating over Saimaa. Sial is floating over Saimaa. That means continental masses are floating over oceanic crust. Something like that he assumed. However, here in plate tectonic theory, we are able to understand that plates are not only consisting of continental masses. Rather, together along with ocean floor also, one complete lithospheric slab will be there. This lithospheric slab can consist of some part of continental landmass, some part of ocean floor also. This is the difference. Okay. Now, after understanding these lithospheric plates, you should also understand that there are some major and minor plates. There is one diagram in NCERT, 11th standard NCERT. Yes. Look at this diagram. There are total 7 major plates and then there are minor plates. For example, you can see the first plate which is mentioned here is, I guess, yes, Antarctic plate. First plate is Antarctic plate, then the second North American, South American, and then there is, yes, Pacific plate, then there is Indo-Australian plate, then there is Eurasian plate. There is, so African plate and Eurasian plate. Okay, so this is how total 7 major plates covering majority of the landmass of the earth. Okay, so after understanding this, there are some minor plates in between these major plates. You can see here Cocos plate between Pacific plate and North American plate, Nazca plate between Pacific and South American plate. Okay, so many such small, you can see the Philippine plate is there. Then Arabian plate is there for the Arabian Peninsula. So many such around 200 small plates are located in different parts of the world. Okay, now the interaction of these small plates with the major plates also helps in understanding the formation of landforms, distribution of volcanoes or volcanic activities, as well as the earthquakes around the world. For example, the formation of thousands of islands in Philippines region is actually the result of interaction between the Eurasian plate and the Philippine plate. Eurasian plate and the Philippine plate, and the Philippine plate and the Pacific plate. This is how the ocean convergence that is happening here. So yes, we will understand that in future, but for your information, there are total 7 major plates and several minor plates here. Now let us try to understand the hypothesis here about these plates in plate tectonic theory. Plate tectonic theory explains that these different plates have been wandering throughout the geological past, and at present also they are moving, in future also they will move. Okay, so in past, in present and in future, these lithospheric plates have been wandering or moving in a horizontal direction. Okay, now the force responsible for the movement of these lithospheric plates is convection currents, as explained by convection current theory of Arthur Holmes and further explained by Harry Hess in seafloor spreading hypothesis. Okay, the force responsible. That means these lithospheric plates are freely floating over liquid asthenosphere. They are freely floating over liquid asthenosphere, and the direction of the convection current or the magma in those convection current decides the direction of movement of these plates, decides the movement of these lithospheric plates. Now you must have understood what is happening on the earth's surface. Okay, and the force responsible for the movement of these plates. That means what happened in the past? Plate tectonic theory says that yes, there was Pangea. Yes, there was Pangea, but that was not the origin of the, let's say, all the land masses, as explained by continental drift theory. There was one limitation of the continental drift theory, which said that it could not explain what was there before 225 million years ago. It could not explain what was there, what happened to these land masses before 225 million years ago. However, now the plate tectonic theory successfully explains this. It says that Pangea was there, and Pangea, or the united mass land masses, you can see here, again this is given in NCERT, explaining what happened in the past. You can see 540 million years ago. 540 million years ago, these land masses were spread in different manner like this. Then 420 million years ago, they started coming together. 300 million years ago, again they united, some of the land masses united together, you can see here. And you can see the time period in between them. There was Pangea before 200 million years ago, as explained by continental drift theory. Pangea was there, but Pangea was the result of all these continental masses or plates coming together. Okay, and after 200 million years ago, again it broke. And the masses started spreading away from each other, and this is the present situation, which is also explained by continental drift theory. That means the land masses have been wandering throughout the geological past in different directions. Okay, they have been wandering in different directions, and the present location is what we are seeing today. In future, it may, yes, in future it may go, let's say, join again, or we do not know what will happen. Yes, in future it may join, it may not join. Thousands of years after, let's say, present times, it may again become the Pangea. Okay, it depends upon how the sublayer, or let's say underlying forces, are working. The convection current. It depends on convection current, how they are working, and we do not know in detail about that working of convection current. We do not know about the working of convection current. Okay, so yes, this is how the plate tectonic theory explains the present distribution of continents and oceans. Okay, now after understanding this, we are able to also understand the different kinds of plate boundaries created by plate interactions. Now, in seafloor spreading hypothesis, we are able to understand that the plate is diverging from each other. Let us try to imagine that the continental mass, this is suppose the African landmass. I am just giving the example. African plate, and suppose on this side there is South American plate, and in between there is South Atlantic Ocean. Now what is happening here? That the divergent boundary created between these two plates, African plate and South American plate, divergent boundary is created in this location here. Imagine what happened in the past. These African continent or landmass and South American were together or near each other. In past, they were near each other, and the boundary between them was divergent boundary. That means they were moving away from each other. These plates were moving away from each other. That created the weak zone. Wherein the magma is now continuously coming up. This is called as divergent plate boundaries. You can see the plate nature. Okay, the plates are moving away from each other. Again, let me show that to you on the map here. This is African plate. Give attention here. This is African plate and this is South American plate. You can see here, this is one plate. Try to understand. It includes continental mass as well as this oceanic floor. Together it is one plate. Together it is one plate. Now try to understand that the boundary which is there between these two is divergent boundary. That means the African plate is moving away from the South American plate. And because of this divergence, here there is mid-Atlantic ridge is created. The mid-Atlantic ridge is created wherein new crust is being formed continuously. The new crust is being formed continuously, and that's why it is spreading. Now imagine these were the continental masses only near to each other. Because of the movement away from each other, the new crust is being formed, and that new crust is becoming the oceanic crust. The continental land masses are as it is. The continental land masses are as it is, but the new crust is being formed in terms of oceanic crust, and that's why the ocean floor is widening and widening. And at present we are seeing this Atlantic Ocean. That means earlier there was no Atlantic Ocean. That means there was no Atlantic Ocean. This Atlantic Ocean is created because of sea floor spreading, and this sea floor is spreading because of divergent movement of African plate and South American plate. Are you getting this? Everyone? Okay? Yes. Now after understanding this one type of plate, yes?
So the different boundaries of the oceans seem to have formed between the two continents. This is because of this seafloor spreading, right?
Yes, seafloor spreading happening at the boundary of these two plates. Because of divergent nature of this boundary. Divergent means the plates are moving in opposite direction. Divergent means the plates are moving in the opposite direction. Because of that, the boundary that is created, that leads to eruption of the volcano or volcanic eruption, and because of that new crust is being formed. Okay.
That crust is basically the oceanic crust.
Yes. Now you tell me, whenever we are talking about the sea floor spreading, or whenever we are talking about the mid-oceanic region, that particular region is region of which type of boundary between plates?
Divergent.
Yes, always and always. It is divergent plate boundary. It is divergent plate boundary. It is also alternatively called as constructive plate boundary. Why constructive?
Because it is constructively eroded.
Because, yes, new crust. Because of formation of new crust, it is constructing something new. That's why the constructive plate boundary. Divergent plate boundary or constructive plate boundary, one and same, and it is always located near the mid-oceanic region. Always located near mid-oceanic region, or we can say that mid-oceanic region is the feature where the plate boundaries are always divergent plate boundaries. In this manner we will remember this, always remember this fact. Okay. Now after understanding this, there must be the region where plates must be converging also, coming together. They must be coming together also. So in that region what happens? In that region what happens? For example, let us take example of this South American plate and Pacific plate. We will take the example of South American plate and this South American plate and this larger Pacific plate. Okay, minor plate, we will not consider the minor plate now because they are part of major plates broken like this. Okay, so what happens here, this larger Pacific plate, being the oceanic plate and being the heavier and denser plate, subducts under the lighter continental South American plate in this region, along this border. It subducts because these plates are coming together. These plates are converging with each other, and whenever there is convergence, the heavier plate subsides under the lighter plate. Heavier plate subsides under the lighter plate. In this case, which is the heavier plate? Oceanic plate, the Pacific plate. Now you can see the convergent boundary is shown like this solid triangles. This is convergent boundary. Now let me show that to you by drawing this diagram here. Now, what happens in the convergence? This is oceanic plate. Suppose this is continental plate, and the movement is like this and its movement is like this. There is convergence, there is subduction. This is called as zone of subduction. This is also called as Benioff zone, but you should not write this in your answer. This is actually some technical term which is used in optional subject. Benioff zone, zone of subduction. Okay, now in this zone of subduction, what is happening is the crust is getting consumed. This is again trench area. This is trench area. The crust is getting consumed and the melting of the crust happens here. Melting of crust happens in zone of subduction, and this melted magma seeks to come up below continental landmass. This melted magma seeks to come up whenever it finds the weak zone in this continental plate, and there is volcanic eruptions happening here leading to formation of mountain ranges on the margins of that plate. On the margins of that place. Okay, so that means these mountain ranges, here the example we were talking about the Pacific plate and South American plate. Which is the mountain range located there? Look at the atlas. Look at the atlas. South America physical map. South America physical map. Name of the mountain range along the yes, Cordilleras is the generic name, but the specific name.
Andes.
Yes, Andes mountain range along the western border of or boundary of South America. Can you locate that, everyone? Okay, now this is the continuous mountain range. Basically this is formed because of the subduction and subsequent volcanic eruption like this. The same is the case with the Rockies mountains. Look at the Rockies mountains in North America. North America physical map. North America physical map. Yes, continuous mountain chain again on the western margin. The same thing is happening, the convergence is happening. So you must be thinking that whether the convergence always happens with oceanic plate and the continental plate. No, the convergence happens, and convergence is of three types. Convergence is of three types. That means just now we talked about continent ocean convergence. Second type, continent convergence. Now this second type, the example here for the second type, continent convergence. That means two continental plates are converging. The oceanic body is not that much involved here. The two continents are converging. For example, Eurasian plate and African plate. For example, Eurasian plate and African plate. What do you see here in Eurasian plate and African plate? Look at this. This is African plate and this is Eurasian plate, like this. So African plate is moving up like this and it is colliding with Eurasian plate. It is colliding with Eurasian plate, and African plate is heavier as majority of the part, though it is continental, but it is also oceanic. So it is heavier and it is subducting under Eurasian plate. It is subducting under lighter Eurasian plate. Now what mountain ranges do we see along this border? What kind of mountain ranges are located here in this part of Europe? Continental part, yes. Locate the mountain ranges. Europe physical map. Europe physical map. Yes. Can you locate the Alps mountains? Can you locate the Alps mountains? Look at their direction of the mountains. Are they parallel to this boundary like this? That means they are formed because of convergence of African plate and Eurasian plate. Alps mountains, they are also folded mountains like Himalayas or fold mountains. Now the same example is Himalayas. Now see here what happens in terms of Himalayas. The Indo-Australian plate, look at this plate, Indo-Australian plate, which is largely oceanic plate. Now which is having the continental landmass of Indian peninsula. This Indo-Australian plate which is having the continental mass of Indian peninsula and here Australia. It is moving in this direction like this, and being the oceanic plate, it is heavier, it is getting subsided under Eurasian plate, and because of that the formation of Himalayas happened. Because of that the formation of Himalayas happened. But let me tell you that folded mountains or fold mountains are not result of volcanic activities. Earlier we understood that. It is not result of volcanic activities. Rather, fold mountains of Himalayas and Alps, they are result of, we can say, the geosyncline forming between these two plates. and further folding of the sediments in that geosyncline. We'll learn that in the next session, how Himalayas and Alps are formed. Okay, so basically the movement is happening. The movement is happening of Indo-Australian plates like this, but this movement is resulting into folding of the sediments between two plates. Folding of the sediments between these two plates. Okay, I am just giving you idea. Yes.
So basically all the folded mountains which are formed are due to this convergence of the continents.
Yes.
Continental plates.
Yes.
So the Ural mountain in the Russia, it separates Russia from Europe.
Yes, Ural mountains are not result of we can say movement of plates. Ural mountains are block mountains, or we can say that they are residual mountains. Okay, Ural mountains are continental mountains, and no, let's say, particular theory explains the continental, we can say, mountain ranges. For example, Aravalis in India. Aravalis are residual mountains, okay, or relict mountains, because we do not know the formation of actual mountains, how they were formed, but surely at present we can understand they are relict mountains. That means the continuous erosion happened of these mountains over thousands of years, and present day mountains are the relict mountains, remaining mountains.
So actually the excited positive that Aravali mountain ranges are one of the oldest folded
Yes, one of the oldest folded mountains, yes, but try to understand their formation is not result of convergence between plates. Okay, the new mountains or young mountain ranges like Himalayas, Alps, Rockies and Andes, they are the result of convergence between plates. Okay.
So
Yes.
what are the four? Alps, Rockies, Himalayas and Andes.
Yes, these are the four fold mountain ranges. Along with that, we have to also understand these mountain ranges are along the plate margins, located along the plate margins or plate boundaries. Okay. Yes. Now, the third type of plate boundary that is created is neither converging nor diverging, rather they are sliding past each other. That means, suppose this is one plate and this is other plate, then if they are moving in opposite direction in this manner, that means they are sliding past each other. This is called as transform boundary. This is called as transform boundary. That means in this particular case, the crust is neither created nor being destroyed. The crust is neither being created nor being destroyed. We have seen in divergent plate margin or boundary, the crust was created. In convergent plate boundary, the crust was consumed. However, in transform plate boundary, the crust is neither created nor destroyed. Is this clear? Now what are the examples? Transform boundaries. Transform boundaries are largely found along the crest of mid-oceanic ridges. Crest of mid-oceanic ridges. For example, let me show you. These lines are actually transform boundaries. Can you see this? Because this mid-oceanic crust is not uniform mountain ranges. They are not uniform mountain ranges. So, yes, in the same diagram we can look at this. Yes, this is the mid-oceanic ridge, right? But this mid-oceanic ridge is not continuous, rather it is like this. Some part here, some part here, some part here, some part here. Can you imagine this? Now, in these two parts, there is actually the transform boundary created. Means this part and the other part like this. This is called as transform boundary. Can you see this transform plate boundary? That means the movement of masses here along this boundary is like this. Not towards each other, not away from each other. Not towards each other, not away from each other. Let me give you one more example between actual plates. There is one transform boundary created near San Andreas Fault. You can see here the location. There is transform boundary created like this. Everyone, pay attention here. Between Cocos Plate and North American Plate near California, the transform fault is created or transform boundary is there, and it has created the San Andreas Fault. San Andreas Fault. There was one Hollywood movie also, San Andreas. Do you know about this? Okay, not interested in movies. Okay, actually that movie is based on this earthquake itself. There is huge earthquake happens in San Andreas, that Californian Valley region, okay, in US, and it is based on that particular earthquake itself. The earthquakes are very frequent in this region, in San Andreas Fault region. Okay, so this is created due to transform boundary. Remember this. Okay, transform boundaries are associated with faults. Okay, generally they are associated with faults, and most of the transform boundaries are located along the mid-oceanic region. But how? In this manner, like this. Okay, so that means they are not, the plates are not moving away from each other or towards each other, rather they are sliding past. That means this becomes a small landmass, this becomes a small landmass, and they are moving like this. Okay, so that is called as transform plate boundary. Again I am repeating, no crust is formed, no crust is consumed near transform boundaries. Okay, is this clear? Now, after understanding the three types of boundaries, you will also understand that the location of different volcanic eruptions, volcanoes, as well as the tectonically active regions, or we can say earthquake prone regions, are also located along the plate boundaries. Tomorrow we'll understand and try to find out what is this Pacific Rim of Fire or Circum-Pacific Ring. Last year we have seen that question, mains examination. Have you seen the questions from the past year or at least 2020 examination? Let me read that to you, the question. Yes, discuss the geophysical characteristics of circum-Pacific zone. Discuss the geophysical characteristics of circum-Pacific zone. 10 marks. So yes, you should be aware what kind of questions are being asked from the physical geography. So basically this is circum-Pacific zone. Can you see this circum-Pacific zone? This is the tectonically most active region in the world. All the majority of volcanoes and earthquakes are located along this circum-Pacific zone. Okay, tomorrow we will try to understand that, all these things. Distribution of all the volcanoes and earthquakes. Okay, so this is how we have to understand the plate boundaries and different landforms and processes. Tomorrow we will try to understand the formation of the Philippines islands, group of islands, the arcs and festoons formation, then Caribbean islands and this formation of Caribbean islands in this region. Okay, the formation of Himalayas and Alps, how they are formed. So all these things tomorrow we are going to understand in detail. Have you understood all three theories, tectonic theories? Continental drift theory, sea floor spreading and plate tectonic theory. Okay? Yes, so tomorrow first we'll write down all these things regarding plate tectonic theory and the remaining part of application of this theory. Basically application is that plate tectonic theory explains the formation of these different landforms, islands and mountain ranges. Okay, so that part we will try to cover tomorrow. Yes, any question, any doubt?
Yes.
Tell me.
Sir, in 2018, I guess, sir, in 2018, this exam, there was a question asked, define mantle to make.
Yes, mantle plumps. Yes, yes.
Yes, sir, plums.
Yes.
And explain its role in tectonics. So, what is those mantle plums?
Yes, tomorrow I will explain that also. Tomorrow I will explain that phenomenon also for plate tectonic theory. Yes. Yes, formation of Himalayas, tomorrow we will explain that also, how they are formed. Anything else?
So, all the volcanoes, all the mountains which are formed by the volcanoes, sir, are they due to tectonics or there is some other issue?
See, most of the, almost we will say 99%, but some of the intraplate volcanism happens, intraplate volcanism. For example, in Pacific Ocean itself, at the center of Pacific, the volcanic eruptions that happened in Hawaii, okay, Hawaiian islands and Hawaiian volcanoes, they are actually at the center of Pacific plate.
Under the mountain, yes, sir.
Yes, at the center of Pacific plate. So intraplate volcanism and intraplate earthquakes, they are actually not, what you can say, explained by plate tectonic theory. This is the only criticism or limitation about plate tectonic theory.
Okay, yes, sir. And there is some mountains in African region also, Mount Kilimanjaro and Mount Fuji.
Yes,
These
yes.
are volcanic mountains, formed with the volcanic level.
Yes, yes. But they are along the plate margins, okay. They are part of circum-Pacific ring.
Okay.
Yes, yes. Some of the volcanic mountains and tectonic activities that are happening in the Rift Valley region, especially in Africa, that is not explained again by the plate tectonic theory, or the intraplate earthquakes that are happening in the fault regions in India also, like Bhuj earthquake that happened, that is not along the plate margins. Okay. Yes, any other question? When should optional preparation start? Yes, what is your optional subject? And when are you going to attempt examination? Whether it is going to be 2022 or 23? Yes, next year. Then yes, optional should be started right away itself. Before December, complete your optional preparation also. Okay, before December, complete your optional preparation, because from January you will be starting for specifically prelims examination. So before or up to December end, optional with GS mains examination, it should be completed. Okay, any other question?